Hi everyone, we're going to identify and graph the polar equation r equals 1 minus cosine of theta. Now this is going to be a cardioid. I will show you that in just a moment, that form for a cardioid. But right now let's do our test for symmetry. And the first test is see if it's symmetric with respect to the polar axis by replacing my theta with negative theta. So we get r equals 1 minus cosine of negative theta. Well, since cosine's an even function, I can change this to a positive and I get 1 minus cosine of theta. Since it is equivalent to our original equation, our test passes. So it is going to be symmetric to the x-axis. Now let's check for symmetry with respect to the line. Theta equals pi divided by 2, which is the y-axis. And in this case, we're going to replace theta with pi minus theta. So we're going to write r equals 1 minus cosine of pi minus theta. I'm going to use my difference formulas for cosine and expand this as equals 1 minus cosine of pi times cosine of theta plus sine of pi times sine of theta. All right, I should have scooted it down a little bit. All right, this sine of pi is just 0. Cosine of pi is negative 1. All right, so basically, you have two negatives. You're going to get r equals 1 plus cosine of theta. Since these two equations are not equivalent, this test fails. It's not going to be symmetric to our y-axis. The pole question, if it's symmetric to the origin, all you do is substitute in r by negative r. You just get negative r equals 1 minus cosine of theta. And obviously, they are not equivalent. So it's not symmetric to the pole. Now this is what I meant by this is a cardioid. You can put a 1 in here. Since these two numbers are the same, so RA is 1, and they're the same, then we're going to have a shape like this. Now ours is symmetric to the pole and not to the y-axis. This one was symmetric to the y-axis. So let's graph this, and based off our symmetry, we're going to assign values of theta from 0 to pi. All right, so let's do that. I have 0 to pi, and you just substitute in the values. You're going to get 0, 1 minus square root of 3 divided by 2. That's approximately 0.1. At pi divided by 3, we're going to get 1/2. At pi divided by 2, we're going to get 1. 2 pi divided by 3, it's 3/2. At 5 pi divided by 6, that's going to be 1 plus square root of 3 divided by 2. That's approximately 1.9. And at pi, we're going to have 2. So let's substitute in some of these values. At 0, we're at 0. At pi divided by 6. Now, since I want to make this a little bigger, I'm going to go by 2. So I'm going to count this as 1. And this is 2. This is 3. I'll do it on the axis. This is going to be 1, 2, 3, and 4. Just so you can see it better. So at pi divided by 6, we're at 0.1, which is still pretty close to 0. So I'll just put it out here. All right. At pi divided by 3, we're at 1/2. So we're getting out further. If this is 1, this would be 1/2. Yeah, right there. So we're swinging around this way. At pi divided by 2, we're at 1. So this is the part we're looking at. And then at 2 pi divided, whoops, made a mistake there. 2 pi divided by 3, we're at 1.5. So let's go out. This is 1.5 here. So it's going out this way. And at 5 pi divided by 6, it's almost at 2. I'm going by 2, so this is 1, 2. So it's really close to here. And at pi, we're at, this is pi, we're at 2. 1, 2. So this is this half here. And now it's symmetric to the pole, to the x-axis here. So I can substitute and come back around. And at 11 pi over 6, it's going to be 1.1. At 5 pi over 3, it's going to be at 1/2, which is right here. So it's coming around this way. At 3 pi divided by 2, it's at 1. At 4 pi divided by 3, it's going to be at 1.5. So 1.5 here. And at 5 pi divided by 6, it's at close to 2. So that's going to be 1, 2, very close. And you swing back around. So there you go. And let's make it all the same color. Thank you. Have a nice day. Bye-bye.